Okay, let's get started. Well, I wish we can just dive right into this problem here and start using the Pythagorean theorem here, this little formula, but reality says you have to be very, very strong at some things that we've covered before. Stop, hit pause, look at these three columns, review how to simplify radicals, what things can't be simplified, and then go to this little page is a little bit more to review. We're going to use these skills, these facts about radicals moving forward. And then in order to solve for a lot of today's stuff, to solve for variables, we're going to be using this fact right here. Well, something that we learned the last few weeks here about the square root of x squared. And fundamentally, when we take the square root of x squared, you better know that that equals x. So we're going to use that fact as we solve for these four basic problems in here before we get started with Pythagoras. So if I have x squared equals 10, that's basically asking a question, what number times itself is equal to 10? Well, in order to solve for this, we are going to square root both sides. And this little catchphrase here says, hey, look, when you square root both sides, don't forget to do plus and minus. Now I'm going to explain what plus and minus means in a moment, but what this means is the variable here, x squared, now becomes x because you just took the square root of x squared, and then the answer on the right is just this plus and minus the square root of 10. Now this is actually two answers. I'll explain a little bit further these two answers, but that's the answer. You can't simplify the square root of 10, and so you're done. In this case, I want to get x by itself. Right now, I don't have x by itself. I have x squared. So I want to square root both sides. Don't forget about plus and minus. So this equals x plus and minus the square root of 17. Now, once again, the square root of 17 cannot be simplified, so we're stuck right there. That's my two answers. In this case, I'm going to square root both sides. Don't forget about plus and minus. This equals x equals plus and minus, the square root of 20 can be simplified. That's 2 radical 5. And over here, we have this square root, x squared equals 8. And once again, I'm going to square root both sides. This equals x equals, and once again, the square root of 8 can be simplified. So that equals plus and minus 2 radical 2. Let's talk about that plus and minus for just a little bit more. So if I have a number, and I square it, and it equals 49, you have to fundamentally try to understand that there's actually two answers that could be correct here. Notice, if x was equal to positive 7, for example, that would equal 49. And if x was equal to negative 7, and I squared it, that would be 49 as well. So notice there was two answers here. That's why x would be plus and minus 7 as your two answers. So let's keep all that in mind as we tackle these four examples. Here are the first two, and we have a right triangle, so therefore we can use Pythagoras. Please try to recognize that this is the number that goes by itself, and that's always going to be the hypotenuse. So when I set up this equation here, I'm going to go 7 squared plus b squared equals 25 squared. Well, 49 plus b squared, whoops, let me write that again. B squared equals 625. I'll bring the 49 on the other side, that is 576. And now I have to square root both sides because I don't want b squared. So if I take the square root of b squared, it ends up being b. And so this is actually plus and minus 24. Why is it 24 a whole number? Because 576 is actually a perfect square. It turns into 24. So I just found two algebraic solutions, but in the context of this problem, which is geometric, it has a picture, b can only be positive 24 because b is a length of a side. It's not possible for it to be negative. So let's try this other problem in here. I have a squared plus 3 squared equals 5 squared. So I got a squared plus 9 equals 25. A squared equals 16. Once again, I don't want a squared, I want a. So I need to square root both sides. So a equals, ooh, this is plus and minus 4. But in the context of this picture, a can only be positive. So it's 4. Before we do the last two, I want you to be aware of a little catchphrase called Pythagorean triples. What's a Pythagorean triple? That's where all 3 sides of a right triangle are whole numbers. So this one would be a Pythagoras triple. 5, 3, and 4. And here, they're all whole numbers. So this would be a Pythagoras triple as well. Let's take a look at some Pythagoras triples. These are pretty famous in here. And so here, it looks overwhelming to see these many triples in here. But look, 3, 4, 5 is actually the very first one. And I want you to also take notice, if I doubled 3, 4, 5, I would get 6, 8, 10. If I tripled 3, 4, 5, I would get 9, 12, 15. If I drew, or I would also, and all family members. Then there's lots more. I can multiply by 6 or 8 or 12 or 100 or 1,000,000. 7, 5, here it is. Right here. 7, 24, 25. And if I found their family member, if I times it by 2, notice 14, 48, and 50, that would also be a family member. Pythagoras members, my family member, and there's lots and lots of other families. In fact, every time you see the word primitive, the family. So the last two examples here, keeping that in mind, and think of Pythagoras triple or it's not, meaning one of the sides, or maybe 2 or all 3, are not whole numbers. So, in this one on the left, notice I'm not using a squared, b squared, and c squared. In fact, all those letters are arbitrary. But the most important fact is the one that's by itself is definitely going to be the hypotenuse. So let's set up this theorem here. I'm going to say 5 squared plus 12 squared, because those are the 2 legs. So we square the legs and we add them together, and that's equal to z squared. So that's going to be what? 25 plus 144 equals z squared. This looks like 169 equals z squared. And when I take the square root of both sides, z actually turns out to be plus and minus 13. But in the context of this problem, once again, z is only positive 13. And now, is this a Pythagoras triple? Well, since 5, 12, and 13 are all whole numbers, yes, indeed, that would be a Pythagoras triple. Let's do our last problem in here. And now, notice that d squared is once again by itself. That is always going to be wherever the hypotenuse is. That's across from the 90-degree angle. So in this case, I have what? 2 squared plus 4 squared equals d squared. I got 4 plus 16 equals d squared. 20 equals d squared. And I don't want d squared, I want d, so I have to square root both sides. So d is technically plus and minus 2 radical 5. I can have a negative side, so in the context of this problem, d is 2 radical 5. Is this a Pythagoras triple? No. Why not? Well, 2 radical 5 is not a whole number, but it's still a valid right triangle, and you will see lots and lots of solutions that are triples, and lots of solutions that are not Pythagorean triples moving forward. All right, check out the next video.